Alright, this is the transformer that I was using to test charge. This is out of a car battery charger. It's a 6 volt, 12 volt, 2 amp, 6 amp charger. Now, the thing about this is to get a true split on your voltage rails, you need to, the way it's set up when you get it is like this, where they're both common on the center and it's tied together. And that is right down there. In there, and this is where the coils come in. These two coils. And then you end up with the one bridge, and you need a big one, a 6 amp one or higher. I was using an 8. And then you get your positive and your negative voltage. So this ends up built. I was wondering why it was going too high. This was going to be the negative 12. This was the 0 volts, and this was the positive 12 up there. But this connected back into there was giving it some problems. I was getting 36 volts where it should have been 24. So let me show you how I fixed it. Like that. So basically what I did was I always try to have a donor transformer or donor part or donor transistors, donor screws, all that stuff that you can afford to burn up because something's going to happen or something you can break and test it. So I'm not going to do this one first because this is the one I'm going to use. It's got the heavier gauge wire on it. That one's actually rated at 7 amps. Now this one's rated at 6 amps. And I did modified it. If you see that pin is gone, and then right down here, there's 2 wires coming out. Alright, so I pulled it out of the middle there and stretched that wire. Didn't break it. Don't kink it. You cut it in the middle. And then you have to get some really fine sandpaper and scratch the enamel off right there. So that's what I did. And now let me explain to you how this is going to work. I'm going to make sure this bitch is unplugged. Yeah, it's unplugged. Don't nick the copper wire. That's the worst thing you could do. And then very carefully pull the loop out from the bottom. That's just my little hint to you. I usually curl the loop under, so if you lift that and then snip right where the pin was the last time, they try to usually make the windings the same length and size, and it'll usually work right out. Okay, you gotta clean it up with some sandpaper. Really fine grit. Fine grit sandpaper. Don't go crazy on it. You only want to get the last little bit. You don't want to skin it all the way back because then you're going to run into shorts and all that fucking crap. You don't want none of that shit, do you? So, just do like a little over a 1/4 inch or so. Just kind of skin it up so that you get that varnish off of there. There. So I'm just soldering the two pads on that were left behind. Those were the positive flow. Just getting the wires tinned a little bit. Alright, so what you can see here is I've got the two hots. These are both on the top side coming around this way. And then I've got the white for the negative ground. And then this is the other side of the top. So we've got the high right here, high side, and then the low side, high side, low side. Straighten it out a little bit. Get ready for mounting. And here we go. That's all you got to do for the wiring. And then we've got, of course, the on-off switch. And then on this transformer, right here, there's two more crosses. I can take this off, and instead of being a 6 amp, I can take it to this one and make it 12 volts 2 amps, and then take it to this one and make it 6 volt 2 amps. On the next damn part. Alright, so I got the two AC sided ones set. So this is AC. DC. Rock on. And then I'm robbing this for the screws because they're nice and long and I can get them through the sink. See? So I drilled a couple extra holes in here. So you stick it through. Zip. Tighten it up. Grab on. Set the non-conductive pad down. Set your MOSFET on. Oh, shazam. Well, here, wait. Extras. Always have extras. There. Right there. Extra, extra. We know about it. So we gotta push that down in there. Come on, bitch. Get in there. Come on, snap in. It should snap there. Because I got a nice seed in there now. So if I tighten it too much, it doesn't crack the case. I've been known to do that. So, there's our two MOSFETs for the drivetrain. Those are the final MOSFETs going from the batteries out to the motors right here. These two are going to be this little bandit here, right there. These are the power controllers for charging. So basically, there's going to be another one there. These are going to be controlled by the Arduino. We're going to let more or less through, depending on the output voltage. Now, the batteries specify 13.2 volts is a nominal charge rating. So, I figure if it maxes out at about 13.3 or so, then it should be fine. But I'm going to keep it at the 13.2. Use another voltage divider through here and let the Arduino read the actual output voltage coming out of the two bridges themselves. Okay, so here's the basic setup for the transformer feeds. They're going to come in here on this side. I've got the two full bridges. These are 390K 2-watt resistors up top to kill the capacitor packs. 0.22 ohm or 22 ohm 10-watt resistors down here to decouple. Here in the center, I need one more. Is another NPN MOSFET. This is going to be the driver for the charging circuit. The Arduino is going to latch or dislatch to either bump the voltage up to 13.2 or bring it down to 13.2, whichever way it is, or the amperage is also going to be controlled with this. And then these two over here are the motor driver NPNs. Now these are the final drivers to the track motor MOSFETs. They're both 6 amp, 7 amp, something like that. These are 7 amp. These are 4 and 5 or something like that amp. And then over here you got the two sealed lead acid batteries. These are 12 volt at 7 milliamp hours for 8 hours. Alright, so 7 milliamps. You can go for 8 hours at 12 volts at 7 million. Well, no, that's wrong. Anyway, I just screwed that the fuck up. But anyway, I'm going to publish it anyway because I am not going to re-record this.